3,000 meters below present-day Cairo lies an enormous canyon system. Not a crack, not a fault, not a subtle dip in the bedrock. A canyon. A gorge so deep that if you could somehow drain away the Nile Delta and stand on its floors, you'd be staring up at walls rivaling and in some places exceeding the vertical relief of the Grand Canyon in Arizona. And almost nobody walking the streets of Cairo has any idea it's there. From above, Cairo looks flat, dusty, spread across the wide green ribbon of the Nile floodplain. Minarets and apartment blocks stretch over what seems like endless level ground. But that flatness is a lie. A geological illusion created by millions of years of sediment quietly burying one of the most dramatic river valleys ever carved on Earth. To understand how a canyon like that ends up hidden beneath a city of 20 million people, we have to rewind about 6 million years. At that time, the Mediterranean Sea was going through something geologists now call the Messinian Salinity Crisis. That's a dramatic name, but here's what it means in plain language. The connection between the Mediterranean and the Atlantic Ocean became restricted, and the Mediterranean started behaving like a giant, poorly ventilated bathtub. Water flowed in more slowly than it evaporated. The sea became hypersaline, extremely salty, and thick evaporite deposits began forming. Evaporites are salt-rich rocks left behind when water evaporates. The big question that's been debated for decades is, how much did the Mediterranean actually drop? Older models suggested the sea may have fallen by more than 1,500 or even 2,000 meters, nearly desiccating the basin. That's the empty bathtub idea. But more recent work, especially a 2022 study that carefully restored the buried Nile Canyon to its original shape, suggests the drop was probably closer to 600 meters. That's still enormous. For comparison, during the last ice age, global sea level fell by about 120 meters. This event was roughly 5 times that magnitude, and rivers hate changes in base level. Base level is the lowest point a river can erode down to, usually sea level. When sea level drops, rivers suddenly find themselves flowing into a much deeper basin. That drop acts like someone pulling the plug in a sink. The river responds by cutting downward aggressively, carving into bedrock to reach the new, lower base level. That's exactly what the Nile did. The Nile at the time, sometimes called the Eonile or Proto-Nile in geological literature, began slicing into the landscape of northern Egypt. And it didn't just nibble at the surface, it carved a gorge hundreds of meters deep. Near the present-day Mediterranean coastline, the buried canyon floor now sits about 3,000 meters below the flat delta plain. That number sounds outrageous, and part of it is due to later subsidence, meaning the land sank under the weight of sediment piled on top. Subsidence simply means downward bending or sinking of the crust, but even after correcting for that sinking, the canyon relief itself was immense. Near Cairo, drilling has shown that the base of the Messinian Canyon lies roughly 1,500 meters below the modern ground surface. Once you remove the effects of sediment compaction and crustal flexure, compaction meaning the squeezing down of sediments over time, and flexure meaning bending of the Earth's crust under weight, the original incision depth is estimated to reflect a sea level drop of about 600 meters. 600 meters is not a modest valley, that's skyscraper scale geology. But here's the fascinating twist. The canyon didn't necessarily run all the way to Aswan as a deep 1 to 2 kilometer trench. There's a sharp change in depth near Cairo and Helwan. A nick zone is basically a steep step or waterfall region in a river profile, where the river suddenly drops more sharply. It often marks a change in geology or base level. The Cairo-Helwan nick zone likely represented the southern limit of intense Messinian incision. North of it, the river cut deeply. South of it, the valley was probably much shallower and may have predated the crisis. So how far did this canyon extend? From Cairo northward beneath today's Nile Delta, and then offshore into the Mediterranean basin. In total, the canyon system probably extended on the order of 250 to 300 kilometers from the Cairo region across the continental shelf and into submarine canyons in deeper water. A submarine canyon is essentially the underwater continuation of a river valley. It forms when sediment-laden flows rush downslope beneath the sea, and this is crucial. Part of the downstream canyon may have been subaqueous, meaning underwater even during the low stand. The newer research suggests the Mediterranean wasn't a completely empty desert basin, but still contained 1 to 3 kilometers of water in its deeper parts. So the Nile likely transitioned from a subaerial gorge, above water, into a submarine canyon. In other words, this wasn't a dry, Sahara-sized abyss with a river plunging into emptiness. It was a dramatically lowered sea that still had deep water, and the Nile was carving toward that lowered shoreline. So picture this. Stand in what is now central Cairo 6 million years ago. The Mediterranean is roughly 600 meters lower than today. To your north, the land drops into a massive bedrock gorge. Waterfalls roar as the river adjusts to its new base level. The canyon walls are steep, raw, and freshly cut through sedimentary rocks. And then the crisis ends. Around 5.3 million years ago, the Atlantic connection reopens. Water floods back into the Mediterranean in what may have been one of the most dramatic marine reflooding events in Earth's history. Sea level rises rapidly, drowning the lower parts of the canyon. Marine waters invade upstream, filling the gorge with brackish to marine conditions near Cairo and shallower embayments further south. Sediment begins to accumulate, and here's where the burial happens. Over the next 5 million years, the Nile builds one of the largest deltas on Earth. A delta is the wedge of sediment deposited where a river enters a standing body of water. The Nile Delta thickens to several kilometers in places. That sediment load is enormous, thousands of cubic kilometers of sand, silt, and clay. As that weight piles on, it pushes the crust downward. That's flexural isostasy, the bending of the lithosphere under load. The lithosphere is the rigid outer shell of the Earth. Think of it like a flexible plank resting on something softer beneath, loaded heavily in one spot, and it bends. So not only was the canyon filled with sediment, but the entire region sagged under the delta's weight. That's why near the present coast, the canyon base is now about 3,000 meters below the surface. Compaction also played a role. As sediment accumulates, the lower layers are squeezed, reducing pore space and increasing density. That squeezing lowers the elevation of buried surfaces even further. So by the time humans arrived in Egypt, the canyon was utterly invisible, completely entombed beneath thick layers of deltaic and floodplain sediments. So how did we discover it? Ironically, through engineering and petroleum exploration. Drilling for water wells near Cairo and for hydrocarbons in the Nile Delta revealed something unexpected: bedrock at extraordinary depths. Boreholes near Helwan hit the canyon floor hundreds of meters below sea level. Offshore seismic surveys, which use sound waves to image subsurface layers, showed a massive erosional surface beneath the delta sediments. Seismic reflection data act like medical ultrasounds for the Earth, bouncing sound waves off buried layers and recording the echoes. When geologists mapped the base Pliocene surface, essentially the erosion surface at the end of the Messinian, they saw a long, deep trough aligned with the Nile. At first, some interpreted the over 2 kilometer relief as direct evidence that the Mediterranean must have dropped that far, but the 2022 study took a different approach. Instead of assuming the canyon's current depth reflected the sea level drop, they restored the landscape. They mathematically removed the weight of the delta. They corrected for compaction. They accounted for three-dimensional flexure, meaning they didn't just model a simple 2D cross-section but included the off-plane load of the delta. Once restored, the original canyon shoulders were higher, and the inferred sea level drop shrank to about 600 meters. That's still 5 times larger than glacial sea level fluctuations, but it's not a 2 kilometer abyss. Which brings us back to Cairo. Modern Cairo is built atop a flat delta plain. That flatness hides the fact that beneath it lies the infilled remains of a canyon system that, in raw incision depth, rivaled the Grand Canyon's vertical relief. The Grand Canyon is about 1.8 kilometers deep at its maximum. Parts of the buried Nile Canyon show similar or greater buried relief before correction, though not all of that reflects true sea level drop. So, was it larger than the Grand Canyon? In terms of length, no. The Grand Canyon stretches roughly 446 kilometers. The Messinian Nile Gorge likely extended a few hundred kilometers, including its submarine continuation. In terms of depth at certain points, the buried relief rivals it, but the mechanisms were different. The Grand Canyon formed primarily through long-term river incision, aided by uplift of the Colorado Plateau. The Nile Canyon formed rapidly in response to a sudden base-level drop tied to Mediterranean isolation. Two very different stories, two very different landscapes, both spectacular. And today, one of them is visible from tourist overlooks in Arizona. The other is buried 3,000 meters below one of the oldest continuously inhabited cities on Earth. Every time someone crosses a bridge in Cairo, they're crossing over millions of years of hidden drama. Beneath the traffic, beneath the floodplain, beneath the delta, lies the ghost of a vanished gorge, carved when the Mediterranean fell, drowned when it refilled, and slowly entombed by the patient work of a river that never stopped flowing. It's not on postcards, you can't hike it, you can't stand on its rim, but it's there, and it's enormous. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.